Hello, today we're going to put together the x-axis for the C3Dt/C cantilever printer as seen in the instructables.com with the link below the video. This video, much of it overlaps or is similar to the y-axis that we put together in an earlier video. I am going to only focus on the new items to the x-axis, and I'll fast forward through most of the rest, and then you can skip or you can go back to the y-axis video to see how to actually put together the rail itself. But what's different about the x-axis compared to the y-axis would be the y-axis had the end stop built into the actual rail end, whereas for the x-axis it sits on the rail and it can slide back and forth, so it's more variable. And then what we'll be putting together is the actual entire hot end that is associated with the x-axis, and that's quite a bit of pieces that we see really here, all attaching both the cooling fan, parts cooling fan, the hot end, the inductive sensor, a bunch of wiring. We'll go through that piece and put that together as part of the build of the x-axis. Okay, so if you look at the components, again, we have the aluminum extrusion. Like all other videos I mentioned, when you get the aluminum extrusion, get the ones with the profile in it. And this is because the way things click onto the rail, it actually clicks around this profile. So if we look at the z-axis that will actually be holding up the x-axis, it will go in like this, and there's grooves in here, or little extrusions that will click into the grooves of the profile of the aluminum extrusions. That is part of the design. Try to get the extrusions with the grooves in it. I'm using this linear rail, which is not the same as you see in the Instructable. This is actually slightly longer. The rail itself will have to accommodate that, and it fits. I think the rail is the same length as the Instructable, but the linear rail is actually a little bit longer. The other difference is that the spacing of the screw holes in here are 20 millimeters by 15 millimeters, as opposed to the cheaper rails that are 20 by 20. That's a difference too, but you can get the components from the Instructable for both sizing. I have the 15 by 20 and the 20 by 20 sizing to attach the actual connectors. No worries there. Two fans. I'm using the Noctua fan for the always on fan that will actually cool the heatsink on the hot end. And the Noctua fans are very nice for that because they are super silent. This one is a little bit thicker than the ones I'm used to, but I got this in a trade. I'm happy to use it. For the parts cooling fan, I'm using this little turbo fan. And you've seen the wiring for it in the actual video on wiring the KFB. These turbo fans have a lot of power through pushing through air. It will actually push the air through here in an almost circular motion around the hot end. One of the problems with a lot of parts cooling is that there's just a one-directional cooling, and so it cools fine on one side of the print but not on the other side. I'm trying to get around it a little bit with a more surrounding fan. These little holders will hold on to the actual turbofan. There's a little adapter that will connect a 40 millimeter fan to the standard E3D connector, as opposed to having that tiny little fan that comes with it. Those fans work good, but they are super loud, and hence the Noctua fan. This adapter will take care of that problem. This is the actual connector that holds on to the hot end and the inductive sensor. And we will be installing this one on the rail. This here is a kind of a cable stabilizer. As the cables come out of the hot end and the inductive sensor and the fans, this head will be moving back and forth. And the problem you get with wires is that, like, if they kind of move ahead, they get, like, damaged, or they can fray or whatever. What I'm doing here is I'm actually vertically stabilizing the wires so that there's no friction at the connection points of the actual electronics itself. What will be moving is this head with the wire that goes along with the actual components, so there's no friction at the actual connection points. So that's what that's for. These parts belong to the rail. It's the same story as the y-axis. This rail has a built-in spring that tensions itself automatically. Make sure that you use the 20 teeth pulleys. 22 pulleys again are used because they are wide enough to get around the center of this aluminum extrusion, because the belt will be running inside the aluminum extrusion. And if you take the 16 teeth pulleys and idlers, you will actually be scraping against the edges here, which will damage the belt. Like I said, instead of like having the NEMA connector with the built-in end stop, this one we're using a variable end stop because the actual hot end needs to stop kind of at this side of the belt or on the rail, not at the end of it, because you will be past the z-axis and that won't reach. And then this is the actual connector for the end where the spring goes in to the rail. Okay, with that all set, I think the first thing we will do is we will actually start putting together the entire hot end component. That's this piece here. And what goes in it is the hot end will go in like here, and it should fit around. And now if it does not fit exactly, what you can do, and that depends what printer, the screws will probably pull it tight. What I use as a trick is I use a little washer that is the exact same diameter as this circle here. And what you can do is you can heat it up. Okay, I think that might be enough. What you do is you push this in here and you push it down and out, and that kind of smooths out the edges, because the thing when this is printed, there is support underneath here, and that support not always comes off cleanly, and by just pushing it down with a little hot washer, it fixes that problem. Okay, and then we're gonna look at this again, and now it slides over proper. That goes the same with this clip here. Oh, it should fit fine, I think. I think once I pull the screws down, you'll find that it all clamps down nicely, and if not, it breaks. I have these cavities here where you can put in the square nuts. When you put the screws in there, you will actually be pulling on the nut and the screw and not the plastic itself, which makes for a very nice tight fit. All right, and we're going to put a 60mm screw in here. Now this is perfectly tight in here. Kind of position the hot end in the way you want to position it, because this should be kind of tight in here as it is right now. By turning the hot end, and you kind of want to turn the hot end to accommodate this fan here, I actually need to loosen this up again and turn it, and the fan will be going over here. That works out nicely, and then the wiring can kind of run through here. Okay, so that is the actual hot end. The next thing we will work on is putting in the inductive sensor. Now we can't really put it in the right position yet because we're going to have to calibrate this once it is in, but you should accommodate for probably a 2mm distance above the actual tip of the hot end. And you can kind of do this by look and feel, but make sure that it is not too far away from the bottom, because once you start testing this, I've mentioned this in the wiring video, but these inductive sensors are built to detect steel or iron, and we are actually going against a aluminum bed, so the distance of 4mm as mentioned on this sensor here is not correct. It's probably more like 2 millimeters. So you really want to keep it close to the tip of the hot end, and then you can adjust it later on to go a little higher. But if you put it too high and it doesn't detect the plate, what will happen is it will basically push the hot end right into your aluminum plate, and that's something you don't want to have happen. Now, actually, let me do this the proper way. I'm going to add these anti-slip nuts on here. Well, it's not very pretty, but that should keep things in place. Excuse me. Okay, and then we will adjust this later once we get to the actual calibration part of the video or of the series. All right, so we have already this wire and then 4 wires of this going up. The next thing we will be adding would be the fan components. We are going to add the fan on here. So we're going to add this adapter, and I think we should be fine using these just plain Phillips screws that are shorter but will grip on. Okay, so that takes care of the 40 millimeter adapter to the actual E3D clip, call it that. And then next we can add the fan. Now we are going to clip it on like this. I want the wiring with the rest of the wiring over here. Normally, when you buy an Noctua fan on Amazon, it will actually be only 10 millimeters deep. These happen to be 20 millimeters deep because this is a specialized PWM fan. All right, that would be the heatsink cooling. Adding 2 more wires to the bunch. So yeah, this sticks out a lot. We'll assume this is going to work out fine, but this fan is very, very big for a heatsink fan. Certainly won't have any problem with heat creep. Alright, and then lastly we are going to add the turbo fan. This is a bit finicky because it's all, the fan itself is tiny, and we're then connecting this to, so the output of the fan, this fits in here, and then we can add these tiny self-tapping screws in the back. Okay, that takes care of the output of the fan, and then this will be the adapter that will allow you to connect it to this bracket here. And again, we're going to use the tiny little Phillips screws. Alright, that's through. And we now need to figure out all of this wiring, get that organized properly. Oh, pop this guy back on. There we go. And this is a long 1.2 meter mess of wiring right now. Now we're going to sleeve this wiring and put it into the actual adapter on here to keep it all nicely in place. I'm going to melt this in place now. I certainly hope I haven't forgotten any wires, because it's too late now. Alright, there's that. I'm going to work the way back, and I'm going to shrink this down. Okay, so that takes care of the entire hot end with all of the fans and stuff included. So I'm going to set this aside, and then we're going to work on the actual rail itself. All right, look at the motor. We're going to attach this, and it'll fit over here. So we have to kind of work it out like we did the last time, how high we place this 20 teeth pulley up, and it's about 2 millimeters up from, or 1.5 millimeters from the bottom. Again, make sure you screw down on the flat flange. Let's see, there we go. This is the height that we wanted at 1.55 millimeters. Make sure you connect both screws so it doesn't slide up and down. Okay, so the x-axis will be on the rail here. We can have the wire in either point inwards or forward. I think I'm going to do it inwards. Yeah. So I'm going to connect this over here. Like I mentioned in the last video, the screws that you use in here, 16 millimeters on this side. On the deeper end, you can go with 20 through 25, although in some cases 25 might prove too long depending on the motor. In this case, it works out, the 25 millimeter long screws. But the problem is that the holes in these motors are only as deep as they allowed them to be. And I think it might be 5 millimeters, but it depends on the length of these screws that are in the back of the motor. They go all the way through to kind of clamp this all together. Okay, so this is going to fit right in there, and again, there's a ledge inside here. Push the rail up as far as it goes there. Okay, then you can put the other end together, which is the part with the string in there, and the went somewhere, but I lost it. Okay, so with the idler for the rail, we are going to put in the spring. Actually, let's take that back. I'm going to hold off on that because we are going to add the spring later once the belt is on. The components we're dealing with now to put the belt on, we are going to have a we're not here. The belt is going to go in here. Please check out the video on assembling the y-axis where we go through this in detail. And I will fast forward through actually assembling the main rail right now, because that's all repeated from the video in assembling the y-axis. Link for the y-axis below. Okay, we have the belt on, we have the rail on, the belt is tensioned. We are now going to put the end stop for the X on, and that is just same process as the last time. Remember to clip off these excess soldering bits, because there's only so much room in this case itself. Alright, that went in perfectly, good. And then we are going to use this one goes in here like this, but make sure that the screw is not too long, because the T-nut in here right now is sharing the space with the belt, and you don't want the belt to be grinding against the screw. I'm not going to tighten this too much yet because we're going to have to move it in place, but here we go. So now we have the full X rail in place. We can now add the hot end to this. Alright, so now this one here is going to be the cable organizer. So we are going to 14 millimeters. It's this one here. Yes. So that goes through here. And then, okay, now we have the entire x-axis running on the belt here. Looks good. And we are going to put this wiring in place with this clamp here. There we go. What's left is sleeving these wires. We can do that right now. Okay, so then this way I'm going to wrap the sleeve over here, and that makes it all look nice and tied together with the full shrink wrap. So again, we're going to take okay, and there we have it, a fully assembled X-axis ready to be assembled onto the C3Dt/C Cantilever printer. If you like this video, give me a thumbs up. Subscribe to my channel. If you really want to help me out, hop over to my Patreon account, link below the video. I'm doing all of this for free, get very little in return, if nothing. I can use all the help I can get. Thank you and goodbye.